Welcome back to another week of linear algebra through modern applications. I'm your favorite math ninja. These are our competition t-shirts for the math organization I run at school. And figured I'd wear one today while I tell you a little bit about what's going to happen this week. So this week we're actually going to try to look not just at vectors but at changing vectors or transforming them primarily from space vectors to space vectors, plane vectors to plane vectors. Eventually we'll get into moving from one space to another, but for now we're going to stay mapping one space back onto itself. Sort of a very natural thing to do and to think about. A way to model motion, which is primarily the avenue we're trying to appeal to. Anyway, we're going to look at just the general idea of a linear transformation and how you can think of a linear transformation in terms of matrices. Matrices are probably something you've seen before. We're going to look at them in a slightly different way. The normal matrix multiplication things you've always learned are still going to hold true. We're just going to view them slightly differently. We're going to take advantage of the standard basis vectors as a way to get at how to create the matrix of a linear transformation, or the matrix associated with a linear transformation. I think it's pretty straightforward. Then we're going to peel back to the three basic transformations, linear transformations you saw in geometry: reflections, rotations, and dilations. Form their matrices and play around a little bit with some transformations there. Then we're going to do something that's a little more abstract. We're going to look at the vector space of polynomials of a certain degree or less. When you add two polynomials of degree, say 5 or less, you get another polynomial of degree 5 or less. When you multiply a polynomial of degree 5 or less by a scalar or a number, in this case we're going to be looking at the integers, it again is a polynomial with integer coefficients of degree 5 or less. So that's a vector space. And we're going to look at differentiation, standard thing you learned in calculus. I believe all of you have seen it. And we're just going to try to come up with how do we use these techniques of creating the matrix of a linear transformation to create the matrix for differentiation on this vector space. It's sort of a fairly abstract idea, but in this case, very easily computed. But it gives you a sense for how there doesn't need to be any geometry behind the workings of linear algebra. So while we primarily use geometric motivation for most things, I think this example shows you that linear algebra is going to be able to stretch itself and be useful in a lot of different areas of mathematics and other applications. By the way, that's my cat Bilbo. I'm going to try to pan over to him. He's 17 years old, so he's comes outside and plays around with me whenever he sees me out here. Anyway, lastly, I want to end this week with sort of just a general discussion about how things are going in the course. It looks like most people are doing a fairly decent job of assimilating information about the mathematics and the use of GeoGebra to do it. Some phenomenal demonstrations by some of you, and truly that leads us to another place that I want to go in the course, which is I need more interaction from or in between you guys, y'all, because you could see some of the great things I'm seeing done by some of your colleagues. So look forward to some minor changes in the following week, a little more group work, a little more work where I'm not going to be presenting the content. I'm going to ask you to solve some problems and think about things, and in small groups make some presentations to the entire class. Anyway, as usual, if you have any questions, any concerns, anything that you need to work through that's individual or even maybe course related, feel free to contact me at any time. Set up a Skype. Email is typically the quickest way to get a quick response from me, but if you need to talk, you can always use You Can Book Me to find me. Anyway, have a great week, and I look forward to looking at more of your great work this weekend and next week. Bye-bye.